All right, here's solutions to perfect problem 4. Um, Basically, you're finding things we already know. You're proving these 6 derivatives or these 6 things that are given. But now we're doing it a little bit differently. I think in the past we used the quotient rule to figure a bunch of these out. Maybe some product rule in here. Now we're going to use the chain rule primarily. So for this first one, the way to do it is that the derivative of secant, you have to note that secant is the same as 1 over cosine. But 1 over cosine you could write as cosine raised up to the negative 1 power. So instead of viewing it as 1 over cosine, which you need the quotient rule to do, if you use it as cosine to the negative 1 power, then we can take the derivative using the chain rule. Derivative of the outside function, x to the negative 1 power, bring the negative 1 down in front. But then we're not done, we still have to multiply that by the derivative of cosine of x. Derivative of cosine is negative sine, so we get negative 1 cosine of x to the negative 2 times negative sine. In other words, the negative and the negative cancel, so we have sine of x over cosine squared of x, which we could write as sine of x over cosine of x times 1 over cosine of x. And if you write it like this, sine over cosine is tangent of x. 1 over cosine is what? Secant of x. And so we get the derivative of secant is just tangent times secant. Secant times tangent, whatever, same thing. Here's part A. Part B. Part B says find the derivative of what? Cosecant. It's pretty similar to part A. Now you have to recognize that cosecant is 1 over sine, but we could also think about that as sine of x raised up to the negative 1 power. So if you use the chain rule, the negative 1 comes out in front. But then we're not done. We have to multiply that by the derivative of sine. Derivative of sine is just cosine. So we get negative 1 sine of x to the negative 2 times cosine of x. And I think this is the same as negative cosecant times cotangent. To show that, we could say, well, it's negative. Sine, this is sine of x to the negative 2 power is the same as sine squared of x in the denominator here. So I got negative, let's see, I want cosecant times cotangent. So negative 1 over sine of x times cosine over sine, which sure enough is negative cosecant of x times cotangent of x. All right, next one, part C. Maybe I'll stick this over here. Part C says find the derivative of tangent. Okay. And in part C, we're allowed to use the product rule, just not the quotient rule. So the way we could do this is say that tangent is the same as sine over cosine, which is equal to sine of x times cosine of x raised up to the negative 1 power. Actually, I don't like it written like that. What I had written there was correct, but when you write the cosine and then negative 1 right there, people think you're talking about arc cosine. So I'm going to put the negative 1 up here. Anyways, sine divided by cosine is the same as sine times cosine to the negative 1 power. And if you write it like this, we can take the derivative. We'll have to use the product rule. This is the derivative of sine of x times, leave the second one alone, cosine of x raised up to the negative 1. And to that we want to add derivative of cosine of x to the negative 1 power times sine of x. And I think we'll finally get a chance to use the chain rule here. Derivative of sine is just cosine. So this is cosine of x times cosine of x to the negative 1 power plus the derivative of cosine to the negative 1. All right, if I use the chain rule, I'm going to get the negative 1 down in front and then leave the cosine of x alone. Then I'm not done. I have to subtract 1 from the exponent to get negative 2. Still not done. I have to multiply that by the derivative of the inside function, in this case cosine of x. And then remember, that's just this part right here. Don't forget about your sine of x out here. All right. Cosine of x times cosine of x to the negative 1 power. That's just 1. That's cosine over cosine. That's just 1. Over here, yeah, whatever. Minus cosine of x to the negative 2 times derivative of cosine is negative sine. Oh, that got kind of messy all of a sudden. Let's try that again. So all I did from this line to this line is cosine of x times cosine of x to the negative 1 is just 1. Over here, derivative of cosine is negative sine, and then I got this sign right here. All right, I trust this is going to work out. So I got 1 minus, the minus and the minus cancel out, so I have 1 plus. On the bottom I have cosine squared, and on the top it looks like I have sine squared. I'm hoping I can show that this is equal to secant squared. A couple ways you can get there. This right here is tangent squared, and you might know that 1 plus tangent squared equals secant squared. But if you don't know that, what you could do is get a common denominator and say I got cosine squared over cosine squared plus sine squared all over cosine squared. So what I did is I say 1 is the same as cosine squared over cosine squared, and then put those together. And the reason that's helpful is now I have this Pythagorean identity here. Sine squared plus cosine squared is just 1. 1 over cosine squared is just secant squared. Oh, my pen's not working very well all of a sudden. Maybe that means this problem's too long. Oh, and I'm only on part D, but okay. Let's keep going. Part D, find the derivative of cotangent of x. All right, a few different ways you can do this. How about one option? I'll probably just do one option. Man, this is annoying. One option is to say that the derivative of cotangent of x is really just the same as the derivative of 1 over tangent of x. So you could say cotangent is what, cosine over sine, or you could say it's 1 over tangent. The reason it might help to say it's 1 over tangent is because then you can say all I need to do is take the derivative of tangent of x raised up to the negative 1 power. Useful because, well, it's got the chain rule written into it, but we already know the derivative of tangent. We figured that out here. It's secant squared. So what we can do here is take the derivative of the outside function, this raised up to the negative 1 power, and say this is negative 1, leave the inside alone, times the derivative of tangent. How am I doing on room? Not a whole lot. And the derivative of tangent is just secant squared. And now if I change everything into sines and cosines, I got tangent of x to the negative 2. Oh, okay, well, tangent of x is, should I write that? No, I don't have enough room. It's sine over cosine. So sine over cosine squared is sine squared over cosine squared. But to the negative 2 power, I'd have to flip that upside down and say it's cosine squared over sine squared. Then I want to multiply that by secant squared. Secant is 1 over cosine, so secant squared is 1 over cosine squared. But what's nice here is cosine squared cancels with cosine squared. What I'm left with is a negative 1 over sine squared. 1 over sine squared is just cosecant squared, which hopefully is what I was supposed to get. Nice. So there's one way you could do this. There's lots of ways you can do these, but there's one of them. And then the last guy says take the derivative of sine squared plus cosine squared. And the way we'll do this is we'll first say the derivative of sum is the sum of the derivatives. So I got to figure out the derivative of sine squared of x. And then to that I want to add the derivative of cosine squared of x. The good news is I can figure out both of those using the chain rule. This is sine of x squared. So I bring that 2 down in front and leave sine of x alone. Now it's raised up to the 1 power. And then I multiply that by the derivative of sine. Over here, again, this is cosine of x squared. Take that 2 down in front. I think in this line I'm going to put a little 1 right here, just so you can see that it used to be to the 2 exponent, now it's to the 1 exponent. Maybe that helps, maybe it doesn't. Because I'm using the chain rule here, I still have to take the derivative of the inside function, so I get here. So I got 2 sine of x times the derivative of sine is just cosine, so cosine of x plus 2 cosine of x times the derivative of cosine is negative sine. What I have here is 2 sine of x cosine of x minus 2 cosine of x sine of x. What I have here is 0, which sure enough is what I was supposed to get. Alright, so there is the end of this perfect problem. Just I guess I can check all these off now, huh? Don't really know why I put the check in the first place, but now they're all checked. That's the end, finally.